Hello and welcome to the day 9 of Advent of Code. Okay, let's read the task. You ride the camel through the sandstorm and stop where the ghost's maps told you to stop. The sandstorm subsequently subsides, somehow seeing you standing at an oasis. Okay. Another giant floating island. I like that. This one made of metal. That's pretty good. You must that must be where the parts to fix the sand machines come from. Wow, that's a long supply chain. That's even a hand glider. There is even a hand glider. Oh, okay. Partially buried in the sand here. Okay. So you have some kind of oasis and sand instability sensor. And analyze your surroundings. Okay, it produces a report of many values and how they are changing over time. Each line in the report contains the history of a single value. A time series database. Nice. To best protect the oasis, there are 6 numbers here, 6 here, and 6 here. To best protect the oasis, your environmental report should include a prediction of the next value in each history. To do this, start by making a new sequence from the difference at each step of your history. So here's the difference is 3, here's the difference is 2, here it is 3, 3, 3, 15. Okay. If that sequence is not all zeros, repeat this process. Once all of the values in your latest sequence are zeros, you can extrapolate what the next value of the original history should be. Is this some kind of a fixed point algorithm? Okay, in the above dataset, the first history is just monotonically increasing by 3. Because the values increase by 3 each step, the first sequence of differences you generate will be 3, 3, 3, 3, 3, 3. Okay. Note that this sequence has one fewer value than the input sequence, because at each step it considers 2 numbers from the input. Oh yeah, it has 5 differences, yeah. Since these values aren't all 0, repeat the process. Okay, and the next sequence, so the difference of differences is 0, 0, 0. Okay. This means you have enough information to extrapolate the history. Okay. To extrapolate, start by adding a new 0 to the end of your list of zeros. Okay. Because the zeros represent differences between the 2 values above them, this also means that there is now a placeholder in every sequence above it. Okay. So, if I know that the difference between this and this is 0, I know that A is 3. If I know that the difference between 15 and B is between B and 15 is 3, I know that B is 18. You can then start filling in placeholders from the bottom up. Okay. Okay, so yeah, I understand this right. Next value of the first history is 18. Finding all 0 differences for the second history requires an additional sequence. 1, 3, 6, 10, 15, 21. Okay. All the differences here are 1. And if I add a 0 here, that means this becomes 1, this becomes 7, and this becomes 28. Yeah, and that's exactly what happens here. Okay. Okay. So the next value of the second history is 28. The third history requires even more sequences. Good. What is the sum of these extrapolated values? So you take 18 for the first sequence, 28 for the second sequence, and 68 for the third sequence. And then you add them up, and that gives you 114. Okay. I think I have the pieces. Okay. Yeah, also let's get the input. Let's save it. Oh, where am I? Okay, let's copy the example, which is here. Okay. Finding all zero differences for the second history requires an additional sequence. Okay. Okay. What can be the twist in the second part? Okay, let's just try the straightforward solution and see what happens next. Okay, so this task sounds like a good fit for Haskell again. Let's create a project. Oh, no. You do cobble init first, and then stack init, then stack run. Yeah. Let's open it, and let's think. So, yeah, I can do the parsing because it's very straightforward in this case. So it's the usual. And the parse is takes a string and returns a sequence of sequences. And the solution takes a sequence of sequences and produces an integer which is a sum of the predicted values. Okay. Time series. Okay, that should be it. Now let's think. In order to predict a value, I only need to know the value here, the value here, the value here, and the value, and I calculate the values here. Okay. So how do I do that? Let's call this line front, And let's say that I'm adding another front to it, so it goes in waves which create fronts. Okay, so what I need to solve this, I need to have one front, and then I can just create another front on top of it. Okay. Yeah. Okay. Let's do parsing again, and that should be straightforward. I split input into lines. For each line I split that into words, and for each word I read it. Yeah. Let's do a quick check. Let's just print the input. Stack run example txt. Something, yeah, I forgot to import system environment. And yeah, that concludes the parsing. Okay, now what? I almost definitely will need the list. And I just need to solve it. Okay, so let's leave it undefined, and let's say that, first of all, I need to calculate the front. Let's say that in order to calculate front, okay, so I wanted to calculate the prediction sequences, calculate the front from time series. Let's call it front from time series. So I have a list of time series, and I need to calculate this prediction front. Okay. Time series undefined. So what do I need to do for that? Let's open the example txt. Let's new. Let's close this one, and let's think. So I have 0, 3, 6, 9, 12, 15. Basically, I need to take the element and the next element. So this basically looks like I have the sequence of 0, 3, 6, 9, 12, 15. And if I zip t with tail t, I get what I need. And then I can just dip with minus. Oh, actually, that should be like this. So, and if I repeat this procedure, then eventually I will get to all zeros. So basically, diff time series. So the diff is equal to zip with minus tail of time series. Okay. What's the type of all? All equal to 0. Yeah. It's false. Okay. So I can do unfold to create a sequence of sequences. Yeah, I think that should be it. So unfolder. So what does it do? It takes some state, takes a list of something, and it produces a list of something, and it has a state. Okay, so in my case, what will happen? At each step, it will be producing the last element of something. So let's define this diff ts here, diff with minus and tail ts. So diff s. Okay. I cannot do that. Okay. 6, 9, 12, 15. Okay. Diff s 3, 3, 3, 3. Diff s is 0, 0, 0. And then at this point we stop. Okay. So if I take list on folder and some initial state, which will be the initial series, and then at each step, if all s is 0, then nothing, we stop. Else just what do I produce? So the element is it the last or the first element of the series? No, it must be the last one. Last s, and the next state is diff s, right? And that gives me the front, which is basically 15 and 3. Okay, I would like to see what happens in this case. So let's say that I split this into words, and I map read into that, and all of this must be int in the end. Yes. Okay, let's try that. The front should look like 2, 6, 15, 45. Let's look at the example. Yeah, that looks correct. Okay, so this works, and let's just say that front from time series is equal to unfolder. I take a state. Let's call this go time series, multiple time series, where go is equal to. So go takes some time series, I would say. If all is equal to 0, then s, then nothing else, just the last one from series and the diff from series. Okay. Now What's wrong with it? Here I take the last one and the div. Oh, interesting. Let's call that series here as well. Yeah, what's wrong with it? So why? So unfolder produces so go has type. Okay, okay. And unfolder has type. Yeah, the producer callback and initial state. Oh, yes, yes, yes. I don't want to do that for both, for all of the time series at the same time. Okay, let's say that so let's say that no, I don't want to add a reduce here. Okay, how do I test this? Let's say that time series is equal to parse with file example txt and map front from yes, so that's 15.3. Okay, then predict. So given a time series and a front, actually given a front and a time series, let's predict the next value. Front time series. Defined. So how does it look? What does it look like? Given that I have a front of this kind, and how do I predict the next value? So let's look at the example again. Okay, 0. So I have the front 15, 3, and 0. What do I have to predict? I want to predict A and B. So I have to say that this is equal. This is equal to so 0 is equal to A minus 3. That's why A is equal to 0 plus 3. A is equal B minus 15. That's why B is equal 15 plus A. Okay. And now I just have to walk it back. And actually, the front must be reversed to be useful. Okay, let's reload. Let's parse. Let's map. And how do I calculate the new value from the front? Predict. So I start from 0. Basically, I just fold. Oh, actually, could I just use folder to do that? And I would fold from the right end of the list and that's why I wouldn't need to reverse it. Okay, sounds good. Okay, so if I do a folder on what? Let's say, for example, folder with something on 15.3. I start with the state with the prediction 0. At each state, I have my predicted n. No, actually, I have my front value first, and then I have my and then I have my predicted my rolling prediction. So then I have to say that this is basically n plus t, and that gives me 18. Is that it? Let's try that. Let's say that this is a sum of map predict with okay. Yeah, let's not hurry, and let's just do it step by step. So I do folder here with a plus starting from 0. I don't even need the values, I just need the front, yeah. Wait, is this definitionally equal to sum? So I just need to sum up the front. Perfect, yeah. I like how obvious it is in Haskell, yeah. Okay, now let's solve it. So first of all, I have my time series, and I map front from time series over time series. Then for each one, what can I do? I can predict using this font, and then I can just do sum. Okay, is that it? Well. 113. Okay. I don't think there is much to slip in the cracks here, so let's just try this number. Done. Yeah, Haskell is ideal for this task. So, now, let's commit what I have. Example, input, app, main, what was that cabal file, and what was the stack file? Okay, I think it's status. Okay. Cabal, you can have your license and your changelog. Okay, git commit. Advent of code 2023, day 9. What was that? Mirage maintenance. Maintenance part 1. Now, let's start with part 2. The first part is done. The second part will have some interesting twist. Of course, it would be nice to have even more history included in your report. Surely it's safe to just extrapolate backwards as well, right? Oh. Interesting. For each history, repeat the process of finding differences between until the sequence of differences is entirely 0. Then add 0 in one step in the past before the time series, and then trace back what you have. Yeah, why not? And then I just used the previous input to calculate the sum of the previous extrapolated values. Okay, so let's see. Is this complicated? So first of all, let's switch to solve 2. It is undefined for now. Let's switch to using it. Parsing remains the same, the input remains the same. That's good. So the second part. Feedback. Yeah, that fit past pastFront. So it takes the time series and it produces a front to the left. Let's say that pastFront is equal to. I have time series and it's undefined for now. Okay, so let's move the diff here. It's still useful. Can be shared. Okay, what do I do in this case? Do I just do head as? Wait, is that it? Okay. But yeah, why not? Yeah, let's try that. Yeah, it's solved too, yeah. Right. Okay, diff also needs a type signature now. It's pretty boring, but it's still good to have. Okay, so now let's test, what was that? For example, I have this time series. Let's say that map read over words of this line. This must be int s. Okay. Let's look at the pastFront for s. 10.3.0.2. Good. Why not? Okay. Now, how do I predict? I know this one, and I calculate this value as this value. So this value is the difference of 2 and 2. That's why That's why 2 is equal to 2 minus 0. This value, minus 2, is equal to 0 minus 2. And this 5 is equal to 3 minus minus 2. Yeah, that checks out. So basically, I just need to folder with retrofit. How do you call extrapolation in the past? It's not prediction, it's I remember There was a nice port for it, but retrofit, whatever. So I have a time series and I have an integer. Retrofit time series. Basically, I say that okay, say that what? Minus 0. Let's just write this logic down and see where it leads us. L folder. So I have some predictor value and a value. Then I say that predictor value minus n, and this starts with 0, and this false. The pastFront, let's call this predictors. Yep, so it falls the predictors. Okay, run. Let's repeat s again, and let's retrofit over pastFront for s, and this produces 5. Yeah, that looks sensible, and this can be just replaced by minus. Is that it? Sum of map retrofit. Yeah, I need to calculate the pastFront for each time series in the plural. Yeah. Okay, main example txt. It should produce 2. Sounds good. Let's look at input, and it produces 995. And that is the right answer. I like Haskell.